Okay, this video goes with the Reveal 4.6 Reteach to Build Understanding on Congruence and Overlapping Triangles. So see what we have here. They're telling us that this triangle ACD is congruent. Let me mark it. ACD. This triangle here is congruent to triangle ECB. Is congruent to this triangle here. So the test, those two triangles are congruent. So the best way to do a problem like this is to draw these two triangles separate from each other. So I'm going to draw this triangle here. And on this other triangle here, we'll copy it down here. And then we want to label it from the diagram. So this is triangle ACD. And this other triangle is triangle CBE. And let's see. Now they tell us that these two triangles are congruent to each other. So that means all their corresponding parts are congruent. So let's see what we have that matches. Let me go ahead and match the angles up. So angle E goes with angle A. Angle B goes with angle B. And angle C goes with angle C. And then we have the sides. So segment AC goes between the 2 and the 1 marked angle. So between the 2 and the 1 we have CE. So AC is congruent to CE. CB is between the 1 and the 3 marked side. So on the other triangle between the 1 and the 3 we have CD. So CD segment is congruent to CB. AD is between the 2 and the 3 angle, so that goes with EB. And angle A is congruent to angle E. Angle C is congruent to angle C. And angle CBE, which is the 3 marked angle, is congruent to the other 3 marked angle, which is CDA. Okay, let's move up. Okay, number 2. Ella wrote a proof to show that, move this up, CGA, so this triangle is congruent to BED, this triangle here. Where is her mistake? So first off, she's saying that these are right triangles. That's good. So angle A and angle D are right angles. That's a correct statement. That's the given. A equal to D because those are right angles. Okay, so she's using the givens. AB is congruent to CD, so there's the double marked ones. And AG is congruent to ED, so there's the single marked ones. And what she needs to show then is with side angle side, that this AC side is congruent to the BD side. So with segment addition, we could do this. Since BC is the same between both of these triangles, AB plus BC in the left-hand triangle is going to be congruent to BC plus CD in the right-hand triangle. And then that would prove these two triangles congruent by side angle side. I'll see what she did. So she used the givens. That's good. BC is congruent to BC, reflexive property. That's good. And now from there she jumps to saying that these two triangles are congruent, but what she missed was she needs to do segment addition and actually show that this AC side is congruent to the BD side in the other triangle. So the part that's missing is that segment AB plus segment BC is going to be congruent to segment BC plus segment CD. And together that would be AC congruent to BD, which is what she needs. That's what she needs for the other side. So that's where she messed up. So she's good up to here, but she needed to include this segment addition piece. Then she could say that because of side, angle, side, where we're looking at this triangle here with this side from this part being congruent to this side here, and that's what we need to use to be able to say those are congruent by side, angle, side. Okay, let's move on. Yeah. So let's look here. We want to see what patterns are being used to prove these congruent. Let's look, see what kind of patterns we have here. This is a side, angle, side pattern. It's going to be this one. If we look at this one, this is angle, side, angle, with angle, side, angle. That goes there. This is angle, angle, side, with angle, angle, side. Goes there. And this is side, side, side. So that's side, side, side. So these are the congruent shortcuts that could be used to prove that these triangles are congruent. And then once we have them proved congruent, we know that like F is going to be congruent to C, and C is going to be congruent to F, and so on.